Good evening, everyone, and welcome to another wonderful evening of See and Learn 2019. First off, we want to thank all of you guys for joining us at Lollipops. We really appreciate your guys' presence. And those of you tuning in on Facebook, thank you guys for joining us. We invite you to comment where you're watching from. And if you have any questions at the end of the presentation, please comment and we'll try to get those questions answered for you. With that being said, we do want to thank CaribTrans for making it possible that we can share this with people all around the world. So thank you, CaribTrans. A big thank you to Prince Bernhard Culture Funds and the government of Saba for your guys' support. And a huge thank you to all of our sponsors. Without them, this wouldn't be possible. So thank each and every one of you guys. Woo! And that raffle that's going on, guys, for just $2 per ticket, you guys could be winning some of these amazing prizes. So let me explain to you guys what you guys could be winning. For our divers out there, we have a 2-for-1 certificate for 8 days, 7 nights aboard the Caribbean Explorer 2. It goes from St. Martin to Saba and St. Kitts. Yeah. We also have a 2-night stay at Queen's Gardens Resort and Spa here on Saba, a beautiful resort. Yep. 2 round-trip tickets on the Dawn 2 ferry going back and forth from St. Martin and Saba. Yeah. A wine gift basket from Shea Booba for our wine lovers. Woo! A handcrafted Triton forged knife made by John at Sea Saba. Yeah. A 2-night stay at Travel Inn on St. Martin Island. Very nice. We have 3 prizes from Aquamania, a sunset sail for 2 around St. Martin Island, 2 round-trip tickets on the Edge, and we have a tango dinner cruise for 2 around St. Martin Island. Pretty nice, yeah. And last but definitely not least, guys, we have beautiful glass art made by Joe Bean right here on Saba Island. It'll be a mermaid and a seahorse. About to say seashell. Sorry, guys. Yeah, so some amazing prizes. If you guys want to enter the raffle, it's just $2 per ticket. We'll be doing the drawings on October 27th, which is our closing night. And you do not have to be present to win. Just leave your name, your number, or an email, and then we'll let you know when you win one of these glorious prizes. All right, now it's time to get started, guys. We have Jim Oris that is going to be presenting tonight, and I'll give you guys some background on him. After growing up in Ohio, Jim Oris attended graduate school at the University of Georgia and Michigan State University. There he studied the interaction between ultraviolet rays and sunshine and certain chemicals found in oil, coal, and fossil fuel combustion products. Jim received his PhD in environmental toxicology from Michigan State University and has been a faculty member in the Department of Biology at Miami University in Ohio since 1986. He currently is a university distinguished professor and serves as the university's chief research officer and dean of the graduate school. Tonight, he will be presenting on how oil and water do not mix. Please give a warm welcome to Jim Oris.
Perfect. Thank you, Tiffany, and thank you, everyone, for coming. Thank you to the sponsors for allowing me to be part of this, and to the dive group today, thank you. It was awesome. They helped me do an experiment today. We didn't get to do everything we wanted to do, but we had a great time. Let's do a little interaction to start with. Tiffany? Oh. As she's setting this up, we're gonna do an interaction. So we need to do the Wi-Fi password, and yeah, the Wi-Fi password is capital dub. Oh, get your phones, phones. And I'll give you the internet password here in a second. Phones out. Yes, you're allowed. Please take out your phones. Put them on mute, but please take out your phones. Lollipops is capital W. Capital W. Capital C. Capital C. At. The symbol at. Exclamation point. Lowercase n. The number 3. And lowercase s. S as in Sam. So it is capital W, capital C, at. The at ampersand, exclamation point, lowercase n, the numeral 3, and the lowercase s. Once you get connected, go to www.menti.com, enter that code 642693. Right up here. Okay, let me do it again. Capital WCC, all caps, at, the ampersand, exclamation point, lowercase n, the numeral 3, lowercase s. There we go. And so as you enter your information, this will build a word cloud of the words that you think of when you hear the word oil spill. And so let's take a few minutes, and as people get connected, you'll get to see what the word cloud looks like. After my talk, we'll do this again. And as we're starting to do this, I need to tell you, this is an experiment. And you have the choice to participate or not, because I'm going to use this data as an assessment of my talk in an education publication. So none of you will be identified. It's completely anonymous. You don't have to participate if you don't want to. I will use these word clouds. The pre and post is part of our research. Yes? Oh, if you want to pass around a sheet also? Oh, okay. Do we have a piece of paper we can pass around and write words down? Because I can build the word clouds at the beginning and the end as well.
Do we want to have them shout it out?
Just, yeah.
Alright guys, I'm going to send around this piece of paper. If you guys can please only write on the back side, because you're using the front side for information. So if you guys can write on the back side, that'll be awesome.
You're if you're not on the internet, you can write words. So pass it around. So we'll pass this around as we're getting the talk started. But you're starting to see some words come up. Toxic, death, dirty, disaster are the most, and the more times it appears, the bigger the word will be. And we'll do this again at the end to see if any of the words change. But again, this is sort of a human subjects experiment, and we have permission to do the experiment, and you're completely anonymous, but I have to tell you, you don't have to do it, and you will never be identified, okay? No. We're either live or with the piece of paper going around. So let me say a few words as we're doing this. There's some firsts here tonight. So this is the second time I've been to Saba, twice this year. The first time we came for vacation, my brother and I came for vacation to go diving at this amazing place. And on the first day of that dive, we talked to Lynn, and she found out that I do oil spill research, and she looked at me and said, "What are you doing in October?" And I said, "Tell me more." This is the first time that scientists have measured ultraviolet radiation penetration in the ocean waters around Saba, and for what I can tell, in the Lesser Antilles in general. And I've given hundreds of talks in my life But this is the first talk that I've given holding a beer. That's right. We're all divers, right? Okay. So this is going. You can continue to add your words as we move along and put them on the sheet, and I'll add them later. At the end of the talk, we will do this again and to see if your thoughts changed, okay? So we can move off this, and I'll start the main part of the talk. But you can continue to enter information while you're doing this. Yes?
So if two people enter the same word,
the word gets bigger.
The word gets bigger.
Yes. So the bigger the word, the more times people typed it. Okay.
Let me go back really quick. We need the code.
Oh.
So the code is 64.
Oh, there's the code. All right, awesome. All right, so I called this talk Oil and Water Don't Mix. I wanted to I'll give you a little bit of background on why I'm here and how I got to this point in my life. So the question is, who am I? I have been at Miami University for 34 years. I'm a distinguished professor of biology, but I'm also the vice president of research, and until recently I was the dean of the graduate school. On this topic, I have over 130 publications in the peer-reviewed literature, and I've received over $5 million US in grants to study the work that I'm going to talk to you about tonight. About 10 years ago, I traded my lab coat for a suit coat and stopped being a professor full-time and became an administrator. And so this is also the first time I've given a talk in a T-shirt. I've never seen me with a suit coat on. So I told the dive group today that when I was 5 years old, if someone asked me what I wanted to be when I grew up, and many of you will understand this because you're here, is I didn't say a garbage truck driver, a policeman, or an astronaut. I said I wanted to be Jacques Cousteau. I always wanted to be a marine biologist. And everything I did that surrounded my whole life was to become Jacques Cousteau and be a marine biologist. When I was a junior in college, the Amico Cadiz tanker went aground off the coast of Brittany in France and spilled almost 70 million gallons of oil into the ocean. And I was already interested in the effects that oil had in the environment, but that event changed my life and made me want to study the impacts of oil and oil pollution and combustion products and everything that goes on so that I could potentially make a difference in the world to help prevent these kinds of things from happening. So that's where I come from, and that's one of the reasons why I'm here. Other than that, in science, some people talk about luck. I talk about serendipity. Serendipity is different than luck. Serendipity is being prepared to understand a chance situation so that you can take advantage of it and come up with a new idea or a new event. Serendipity was when Lynn asked me what to do after our first day of diving, and now I'm here and I'm working. This is a work trip. Unbelievable. All right. So we're talking about oil and oil spill, but there's a lot of other environmental issues that are of importance here in Saba and Statia and the Lesser Antilles. So there's invasive species. Today I saw 2 very large lionfish. But there's also terrestrial invasive species. The goats are one of the main issues here. Hunting is a problem in the islands. The crabs and the green iguanas. Construction for loss of habitat. Erosion and turbidity, small particulates from the sediments that wash off the island into the water. Fishing, subsistence and commercial fishing. Overfishing is a serious problem worldwide. Household pollution. If you throw your garbage into a ditch, it's going to run downstream and go out into the ocean. Mining. There's mining here and on Statia. Storms and hurricanes. And with climate change, storms and hurricanes are becoming more frequent and more intense. Tourism. We've loved our places to death. And so as we go out and we say no touch, no take, no nothing, we still bump into things and we still damage. So we love our islands to death. And then I'm going to talk a lot about the last one, shipping traffic. So these are all things to be concerned of. I'm going to focus on shipping and oil. So the program's going to be in four parts. The first part is a brief description of oil and fossil fuels. Then we're going to talk about what I call the next big spill. There will be the next big spill. Part 3 is what happens after the slick is gone. We know what happens during the slick. I'm interested in what happens after the slick is gone. And then part 4 is round 2 of what happens after the slick is gone. So those are the 4 parts. So those of you who go to talks, now you know how long my talk's going to be. All right, part 1, oil and fossil fuels. So fossil fuels are remnants of living things from millions of years ago that got buried under the sediments, under the ocean, and the heat and pressure of the sediments then created these partially decomposed remains of organisms that create coal and oil. Coal is the remnant of terrestrial plants. And when you actually take raw coal and you break it apart, sometimes you can find fossils of leaves and things like that in coal. So it's clearly terrestrial plants. Oil and natural gas are remnants of microscopic marine animals and algae that were died, went to the sediments, got buried, the pressure created oil. So partially decomposed animal and plant materials. There's thousands of uses for oil and natural gas and coal. Almost everything you touch every single day has at least some component of oil or fossil fuel in it. The chairs you're sitting in, the tablecloths, some of the beer we're drinking, the windows, the projector, the computers, everything has something that was derived from oil. They have environmental impacts. So we have to get it out of the ground or out from under the ocean. We have to move it from point A to B. We have to store it, and we have to fix it so that it is useful in its chemical nature. So we make gasoline, we make pesticides, we make medicines. And there are product-specific impacts. So pesticides, for example, or other components of oil. So we've got gasoline, and we've got lubricating oils and hydraulic fluids and those kinds of things. And then we're not even going to talk about combustion. 90% of oil is burned. 100% almost of coal and natural gas is burned. So we're not even going to talk about CO2 and climate change in this talk, but most of these fossil fuels are actually burned for their energy use. Oil and coal are very complex mixtures. Are there any chemists here? Okay, I'm safe. I think I have one virologist, right? Is she here? Yes, the virologist is here. So they're very complex mixtures, and there's different categories of different kinds of chemicals in oil, and I'm trying to make this about the most technical piece of the lecture. But there are things called aliphatics, and the sound of aliphatics means like fatty. And these are long-chain hydrocarbons, carbons and hydrogen, that are waxes and fatty-like aliphatics. So paraffin is an aliphatic, waxes, those kinds of things. Aromatics. Well, oh, there they go. Sorry. It's just taken a while for it to click through. Aromatics are like little Lego blocks of a building block called benzene. And the benzene is a 6-ring chemical, 6 carbons in a ring, that can be put together in many conformations. And so all of these things are based on that one single benzene ring, but then different conformations of that. You know aromatics when you fill your car with gas and you can smell the gasoline. That's the benzene and the naphthalenes, some of the smaller molecular weight ones that are very volatile, but they're aromatic. And I'm going to focus my talk a lot on the aromatic hydrocarbons. When you burn things, you make soot, which is carbon, so particulates. When the boat starts up or the bus goes by and you see that dark cloud, that's soot, and it's toxic. Cations, what we mean by cations are positively charged things, metals. Okay? So there's cadmium, mercury, nickel, arsenic, and other things in oil and coal. And they're negatively charged things. So oxygenated compounds of carbon, sulfur, and nitrogen are also present. So this is a really complicated chemistry. And it has a lot of different effects depending on which group you're looking at. But altogether, it can cause different kinds of major impacts as oil and coal. But each of those categories have their own individual effects. Part 2. Oh, we're going to go for batteries? All right. Well,
You want to go next?
don't know. Oh. 6, 5, 8, 3. My phone went to sleep and my brother needs the code to get into my code. And so now you all know the password to my phone. All right, the next big spill. I like to use quotes from famous people or people I love reading that set the stage for a topic. And Albert Einstein said this: the only two things that are infinite in size are the universe and human stupidity. Oops, I went. Okay. And I'm not completely sure about. Oh, wait, it's really going. Like, wow. There we go. Stop. There we go. And I'm not completely sure about the universe. Okay? So he knew that human stupidity was infinite, but not quite sure about the universe. That takes us to March 24th, midnight, in Prince William Sound, the Exxon Valdez, 1989. This is a quote from the transcript of Joe Hazelwood to the Coast Guard after he had spent the entire day in Valdez drinking at a bar, went to the boat, the pilot brought the ship out of the channel, he was sleepy because he was intoxicated, turned the boat over to the second mate, who was also potentially inebriated, who turned the boat over to the third mate, who drove the boat the wrong direction and drove into rocks. And when you hear this transcript, you can tell that he was not right. He said he was sleepy. I say otherwise. But we've fetched up hard aground. Evidently, we're leaking some oil, and we're going to be here for a while, just so you're notified. Over. And 11 million gallons of oil came out of that boat in a few days. This is where it happened, south part of Alaska. And within a few days, 11 million gallons left that boat and oiled over 1,000 kilometers of shoreline and caused major issues for weeks, months, and a few years. Back in 1989, this is what one of the beaches, this is called Sleepy Bay. It's a very high energy beach, so the rocks that are there because that's the only thing that can survive the winter storms. But you see this guy here is mopping up oil with a diaper, and they also use this beach to steam clean to try and wash the oil off. And we can talk about the strategies, but mopping with a diaper is much more effective than steam cleaning, because when you steam clean, you actually sterilize the entire beach, and the microbes and bacteria that can eat oil got killed. And we went back in 2000 and oops, this is really messing me up here.
Can we actually ask everyone to turn off your Wi-Fi?
Oh, is that what's going?
Getting
I'll just use
in
the
way.
I'll just use the thing.
Please take out your phones once again. Turn off your Wi-Fi, and hopefully it'll all be
Trying
good.
to connect.
Okay.
Yeah.
Okay, thank you. Yeah, phone's back away.
So this is what that same beach looked like 15 years later. And this is one of my graduate students walking on the beach, and we were doing oil assessments. And this is literally in the exact same spot of that previous picture, except for I turned 180 degrees from that picture. The interesting thing is the parts of the beach that were steam cleaned, you could still find some remnants of oil because they sterilized it. The parts that they mopped up and let go, the bacteria ate the oil and it's completely clean. However, if you go up to the storm tide line, you can find what looks like a small road. So the tars and the heavy parts of the oil mixed over time with the sand and gravel, and it compressed, and it literally created asphalt. So this was 15, 20 years afterwards. So you could still find some oil there, but minimal impact after 10 to 15 years. And in fact, we used to work the Prince William Sound for our sampling. We were measuring ultraviolet radiation and impacts of oil, same as what I'm trying to do here. But we did it on the low tide and the high tide. So we had to do something in between tides. You got 6 hours, what are you going to do? So we would fish. And to give you an idea of what's still there and the recovery, this is a halibut that was on the other end of this fishing line. Just for the halibut, that's how we went fishing, right? 172 pounds, 72 inches, it's taller than I am. And a halibut is God's gift to fish. It's all meat, both sides, amazing, amazing fish. So life is good. You can work in a place like Alaska. Okay, next quote. Any Douglas Adams fans? 42. The answer to life, the universe, and everything is 42. In another one of his books, that was in The Hitchhiker's Guide to the Galaxy. In another one of his books, he writes, the major difference between a thing that might go wrong and a thing that can't possibly go wrong is when a thing that can't possibly go wrong goes wrong, it usually turns out to be impossible to get at or repair. Almost 10 years ago was the Deepwater Horizon oil platform explosion. So there was problems down at the wellhead. The shutoff didn't work. The gas came up so fast it hit the platform, and the friction from that gas coming up and expansion caused an explosion. What you don't hear a whole lot about is that 11 people were killed and 17 were seriously injured. That's something we don't really talk too much about. But that was, for me, the most striking thing about this oil spill was 11 people were actually killed and 17 were seriously injured. But it was impossible to get at and repair. The wellhead was at 5,000 feet deep, nearly a mile deep in the ocean. Okay, and I can't think in meters like this, but so divide that by 3, and that's how many meters there were. It lasted for almost 3 months before they could turn it off, and 2 million gallons or more per day were released from the wellhead. Per day. This makes the Exxon Valdez look like a baby spill. At the extent of it, there was almost 47,000 square miles oiled, 210 million gallons. This is 20 times larger than the Exxon Valdez. 210 million gallons of oil released. Fortunately, most of it stayed at great depth. So there was a marine biologist at the University of Georgia that tracked the plume of oil, and it stayed about 1,000 to 2,000 feet deep, but it was 12 kilometers by 5 kilometers by 1 kilometer. And it just moved around the Gulf. And it slowly sank. And luckily in the Gulf, there's a lot of oil seeps, so the bacteria there are pre-adapted to eat oil. And so within 5 years, most of the oil was gone. But the oil came ashore and fouled the marshes. Birds can't fly forever, and they have to land. If they land in the slick, they get completely inundated with the oil, and they lose their thermoregulation because their feathers keep them warm. And when they try to clean their feathers and preen, they eat the oil and it's toxic. The oil also reduces oxygen in the water and you get significant fish kills. The shrimp fishery was turned off and they hired the trawlers to... Anyone not... Beer call? That's right. So I can be the serv... Hmm?
I'll buy you one.
No, I'm good. Thank you. Afterwards. They hired the shrimp trawlers to go out with booms and corral the oil, and then they used siphons to pull as much of the oil out as they could. The oil that they couldn't siphon, they threw flares into the booms, and this is a Zodiac with 6 people in it to give you a sense of scale, and the Zodiac is pretty close to the camera compared to that. So that's like a 300-foot diameter, 100-meter diameter boom and flames going very high. What they couldn't corral and burn or siphon, they used C-130 transport planes filled with what's called a dispersant. Think of Dawn dish detergent. Diluted out, and they sprayed it along the drift of the slick, and that literally acted like soap, dispersed the oil and allowed it to sink below the surface to get rid of the surface slick. But it sank it. And unfortunately, the Corixit, the dispersant, is almost as toxic as the oil is to the aquatic life. So you're using a tool to get rid of the oil that's just as toxic, but you have to use it as a management strategy to get rid of the oil. So these are the world's major accidental spills. I'm not listing on purpose spills. So the largest oil spill in history was in Iraq during the Gulf War, and Saddam Hussein blew up his oil fields. That gets us up to about 500 million gallons of oil released, and that's still an environmental disaster. But these are accidental spills. So at the very top is a Deepwater Horizon, biggest accidental spill in history. The second, Ixtoc 1, was a very similar accident. It was a drilling platform, but within 10 miles of the Mexican shore and only about 300 feet deep. Here's Exxon Valdez, down here close to the bottom. And here's my life changer, the Amoco Cadiz. Okay. Next quote. Who remembers Donald Rumsfeld? He was the Secretary of Defense for George Bush. I can't remember what he was talking about, but he was talking about military things and defense. And he says, there are known knowns. These are things we know about. And he took a lot of grief for this quote, but I think it's very prophetic. There are known unknowns. There were things we know about, but we just don't know. And then there are unknown unknowns. And the unknown unknowns are the thing that I'm most scared about because we don't know what they are, and we don't know what will happen if they happen. But here's a known unknown. In this case, we know the cop is behind the sign. What we don't know is how fast we have to go over the speed limit to cause him to pick us up. It can be 1 mile an hour. It can be 20 mile an hour. He can be reading a book, and I used to play hockey with police people. They would be on traffic stops. They would set their alarm on their radar and actually read a novel as they were waiting for the radar to beep. But where they set that alarm was up to each individual officer on when they were going to choose to stop people. So that's a known unknown. We know the cop's there. We just don't know what the threshold for his or her decision to pick us up. Here's another known unknown, the next big spill. We know one is going to happen. What we don't know is where or when it's going to happen. This is the classic example of a significant known unknown. We know that's going to happen. One happens about every 20 years. We just don't know when and where. So this is a snapshot of shipping traffic in the Western Atlantic, Caribbean, and the Gulf of Mexico. This is one snapshot on one day about a month ago, and every dot in red is an oil tanker. The green dots are cargo ships. The blue are passengers, and I can't remember what the light blues are, but those red ones are oil tankers. Okay? There's a lot of tanker traffic out there, so you can see them coming in and out of the Gulf of Mexico, down south of Cuba, over to the Lesser Antilles, through the Panama Canal, and up and down the northeast coast of South America. There's a lot of tankers out there. Let's zoom in a little closer. You're where the red square is right now. And the classic "you are here" map. So you're here on Saba. Over on Statia is now what's called the GTI Statia Terminal, 15 miles or 24 kilometers away from here. And there's a major oil terminal that's visible as you come in off the boat or from Fort Bay. You can look across the water and you can see Statia, and the only thing you can really pick out on the island is the white oil tanks across the bay. So from outer space, this is what the island of Statia looks like. There's a dormant volcano similar to here, but it has a crater down at the southwest end. And up here at the top, you can see the oil terminal and the tanks. Zoom in a little bit further. This is the terminal. Here's two tankers on the dock transferring oil. And here's another one on Moore. What you can't tell from this slide is the proximity of the tanks to the shore. This is a picture from our flight when we left in June. That's the tanker field, and the tanks run up almost to the edge of the cliff that runs straight down to the water. Now, I haven't been there. I'm sure they have containment. I'm sure they've got best practices for how they deal with the tanks. And so the chances of a major spill from the tanks, I don't know, but I'm sure they have best practices for the tanking. But they're right next to the shore. They're right there on the island, 15 miles away from where we are.
Are there international regulations about this?
There are some, but I'm not an expert in that, so I don't really feel comfortable talking about what I know about that. Okay, so there are regulations. The oil terminal has their own things, and the Dutch government and the independent state of Statia has their own regulations.
Yeah, it's the UN and the Department of Transportation and the UN. That's how it is regulated.
Gotcha.
Yeah.
Okay. But I know they still take single hull tankers. So it was acquired in July and August by a new company, so it's changed hands recently. There are 60 commercial tanks there that hold 14 million barrels. I don't think in barrels, I think in gallons or liters. That represents 588 million gallons or 2.24 billion liters of oil. They have an extensive infrastructure. They can take the largest tankers, these super tankers. But I've been monitoring ship traffic coming in and out of Statia, and the largest ship that's come in and out has been in this middle range right here. Okay. This is a monitoring of arrivals by shipping type. The red are tankers. So not that many, but up to 2 or 3 per day. 2 or 3 per day. And if you look at the tanker traffic, the lower right is the actual just the tankers. So anywhere between 0, 1, or 3, but the median number, the average number, is about 2 per day. And the most important part here is that means that somewhere between 13 and 14 million gallons of oil go in and out of that terminal every day. And that's just this past month. I don't know what happens during the rest of the year, but this is the end of the hurricane season, so I don't know whether it's lower or greater or what, but 13.4 million gallons of oil go in and out of that terminal every day. This is an animation of regional ocean currents, and they switch a little bit depending on what time of year it is, but they always move from southeast to northwest. Stacia's here, Ceba's there. And that's the Ceiba Bank National Park. I'm not an engineer. I'm not going to make predictions on where oil would go. If there was a spill, you guys are here. You decide where you think the oil's going to go. Okay? We are, yes.
Consumers of that said oil, like, where does that oil go?
The oil comes from all over the world.
Yeah.
It comes into port here in large tankers.
Yeah.
Smaller tankers transfer it back onto them, and then they go up and down the coast of the U.S. and South America.
It's
a small-
So
So
the big
our-
tankers bring it from the Middle East and wherever it's coming from. They transfer it here, and then the smaller tankers, the coastal tankers, can then take it up along the coast and distribute it, like up to the refineries in Louisiana or in Brazil or whatever.
But they have not had super tankers here in Stacia yet.
In the last month that I've seen. Okay, so I don't know. Okay, because I was only watching for the last month in preparation for this talk. Okay, yes, sir.
Is there a refinery on Stacia?
Not to my knowledge, no. I think it's only a transfer station. It's a storage and transfer station. Yes.
How many of these transfer stations are around the Caribbean?
I believe this is the largest one, and there are a few others, but this is the main one here in the Antilles, to my knowledge. I'm from the United States. I'm going to tell a U.S. joke. I'm going to be like Donald Trump and say, in my opinion, this is what's going to happen. That way there's no liability because it's just my opinion. Okay, another known unknown, climate change and the frequency and intensity of hurricanes. So the sharks are great because they're like, oh, in a couple years we can go get this guy stranded on the island and we don't even have to go up on land. We'll just swim over and get him. But with climate change, we know that intensity and frequency of hurricanes has gone up. And recently, not too long ago, just a few weeks ago, Hurricane Dorian hit and stayed over the Bahamas for way too long. Way too long. And the oil infrastructure there was not prepared for a Category 5 hurricane or a Category 4 hurricane lasting for 3 or 4 days. And on Grand Bahama, there's an oil storage terminal, and they lost over 1 million, or close to 1 million gallons of oil, and they don't know where it all went because it was a Category 4 hurricane. And there's some oil around that's contained, but they know almost 1 million gallons were lost, and not nearly 1 million gallons were left behind. So if there's a direct hit, and I think the last major direct hit here was Hugo in 1989 for our serious storm. I mean, there's been other major storms, but Hugo was the last really destructive storm here. So the oil infrastructure is also, so it's not just accidents like a grounding or a collision or a leak. It's Mother Nature could cause a problem here too. All right, part 3. How are we doing? Questions? We're at a bar. This can be interactive. Okay. Part 3, after the slick is gone. So the slicks last for months. The oil is stranded. We try to clean it up. The bacteria start to eat it, and it starts going away. What happens after the slick is gone? Let's get back to this group of chemicals called polycyclic aromatic hydrocarbons, or the polyaromatic hydrocarbons. They're natural components of coal and oil. They're present no matter what you do with them. But they also are products of combustion. And so this thing at the bottom is called fluoranthene. It's commonly produced as a result of burning gasoline and oil. They're what we call fat soluble. They're not water soluble. They would rather be in fat. So they accumulate in animal and plant tissues. And they're what we also call phototoxic, which is why I'm here. They absorb ultraviolet radiation, and they pass the energy they absorb from UV onto the animal and cause toxicity. And it's a synergistic relation, so it's an amplification of the toxicity of the sunlight and the toxicity of the oil compounds. So we're talking about the energy from the sun. This is the full spectrum. We're talking about just one small component of it, the UV section. Okay. You can't see UV, but you know UV if you have light skin and you go out in the sun, especially in the Caribbean, without sunscreen on. You get sunburn. So photo-induced toxicity. I'm concerned about fish and aquatic organisms. And when you look at larval fish, there's not a whole lot of pigment there. UV will penetrate straight through that fish. It's pretty clear. It's not until later in life that start developing pigments. This is a mahi-mahi larva. It's completely clear with some exception. The gut and the eyes are the only place where there's pigments. So larval and juvenile fish have a very high surface area and are relatively transparent and are super sensitive to the interaction between oil compounds and UV light. So let's go through how this works. So there's oil. The compounds, the aromatic compounds, stick around for a while. They're the ones that can cause the phototoxicity. They're fat soluble so that they absorb into the tissues of the fish. And within the tissues of the fish, this is a cartoon diagram of a membrane. And membranes are fairly fatty. So they have fat-like properties, so the chemicals accumulate there. But oxygen's moving in and out of the membranes also to help the organism survive. Similar to chlorophyll in plants, these chemicals absorb UV plants absorb visible light. These compounds absorb UV light. Plants use that energy that they absorb to pass it on to other molecules to create sugars and oxygen. UV passes, or polyaromatic hydrocarbons pass that energy on to oxygen and activate the oxygen. So they create free radicals and other activated oxygen compounds that are super toxic. And so when UV is present at the same time that the chemicals are in the membranes, that energy is passed on to oxygen. We create reactive oxygen species, triplet oxygen, hydroxyl radicals, other reactive species, and they set off a chain reaction in the membrane that basically eats the fat molecules up in the membrane and degrades the membrane, causing a super sunburn, like a super sunburn. So you know about phototoxicity if you've ever taken certain antibiotics and you turn the vial around and it says, avoid exposure to sunlight while taking this drug. Or you've done an anti-dandruff shampoo or an anti-psoriasis medicine. It says, avoid exposure to sunlight. It's the exact same reaction. Okay? So the other way to think about this is with sunscreen. We all put on SPF 30 or SPF 50 sunscreen to protect us against sunlight. This poor gentleman here put on PAHs and got negative sunscreen, and instead of SPF plus 50, he did SPF minus 10,000 or minus 100,000. That's how this changes the toxicity of UV. So why are we here? The incredible visibility here. And why do we care? Because if anything ever bad happened here, we want to know the extent of the water column that might be susceptible to this phototoxicity. If UV doesn't penetrate very deep, it's not that big of a deal. There's the slick, clean it up, it gets degraded, goes away. But if the UV penetrates very deep, after the slick is gone, the UV can get down there. It can interact with organisms and cause this phototoxicity. So we're here with a fairly sophisticated instrument that we lower down into the water and measure visible and UV penetration. And the other first about this talk is that no one's ever measured UV here before. I met a gentleman this morning who used to measure visible light, and we're like, can we get that information too? Because we can do some predictions, but no one's ever measured UV here, and I'm going to blow your minds. So I'm going to show you a graph, and the bottom of the bar is going to be the least transparent site of all the sites we've measured. And in this example, 90% of the UV is removed after 17 meters. And the top of the bar is the most transparent sites, and in this example, 90% is removed by 31 meters. So the range of visibility at the different sites around where this data were collected goes from anywhere from a least transparent site, 17 meters, to 30 meters. Let's look at Saba. So this is first view of data of UV collection on Saba Island. Look at the scale. These were collected over the last 3 days. So at the top, Intent Reef, Ted Ran, 90% of the data, 90% of the UV is gone, but not gone until 102 meters. Yes, sir.
In the photic zone, so how deep will light penetrate down to the depth?
So the photic zone at both of these places, I don't have the data in, thank you, Andrew, is almost, it's actually a little less than the UV. So this is there's only 2 places in the world, I found out today, that we've measured UV that goes deeper than visible, and it's Lake Tahoe in California, Nevada in the US, and here. Okay. So the visible's getting down to 250, 300 feet. UV's going deeper. 3 days ago, we were at Pinnacles, almost 100 meters. Tent Wall, 50 meters. Babylon, 45 meters. And this is where we did our first kind of demonstration of how UV can interact with chemicals. And we put vials down to 12 meters. And in this case, this is the vial that had the oil compound in it. This was 5 meters. This was 8 meters, and this was 12 meters down. We were still getting reactions from the UV. So the point is, and then this is the marina, 12 meters. And we know the marinas, every single one of these places, with maybe the exception of Pinnacles, UV penetrates from the surface to the bottom. So when you ask the question, what's the range of the water column that's at risk for phototoxicity? The answer is the entire water column is at risk. So not just the first few meters and the fish that might live up there and the plankton. We're talking about the coral, this hard and soft coral, the baby fish that you see. And when I go diving, I like to get real close and see a little baby fish. They're the ones that are sensitive. This is amazing. This is the rest of the world. These are from published papers. So here's some other sites in the Caribbean. There's the Gulf of Mexico, which we thought was the clearest ocean water we had ever seen. Now I've been to Saba, all right, and other places. This is amazing. So it's great for tourism, diving, and fisheries. It's really scary if there's ever a big accident here.
You've only done a few samples.
Yep.
Will that shrink as you get more data, as comparison to maybe some of the other study sites, or do you expect that range to be what it is as you get more samples?
So I don't think it's going to get any more transparent no matter where we go.
Okay.
We'll find places like yesterday where we did our third dive of the day and it looked like milk in the water, that it will be less. So the only thing that's going to happen to this graph is the bottom part is going to go down. Okay? The upper part's going to stay the same. I don't know what it's like seasonally. We know this week has been super clear out in the open water. But Tent Wall is near shore, and to get a 100-meter reading is just off the charts. So it's amazing. So what do we do with this kind of data? So we measure UV penetration in the water. We can do something like, well, here's what the surface is, and with the relationship that we build with the instrumentation, we can say, okay, where's the 50% level? Or where's the 10% level? Okay? Once we know that, we know the extent of the water column that could be affected by phototoxicity. Then we do laboratory experiments with real live things, and we get what we call a dose-response relationship. Down here you can't see, but the axis is the concentration. Oh, this is the intensity of the UV radiation on the bottom. And this is full sunlight here. And this is nothing left. And then this is the concentration of the oil compounds. And what you can see is that in the laboratory, at 10% UV, it takes about 11 to 15 micrograms per liter of the toxicant to cause 50% mortality. But at 50% UV, it changes by an order of magnitude. So instead of 15 micrograms per liter, we're talking about 1.5 micrograms per liter. And at full sunlight, we get down another order of magnitude, and the toxicity is like 0.15. And so again, at most places, this all happens within the first 10 meters. Here, it's the entire water column. So once we have this information, prospectively, we can predict where this potential risk happens, and so that managers and people interested in preserving systems can either work on prevention methods or build ways to make sure that it doesn't happen here. And again, what we've gotten in the last 2 major oil spills is, well, what was the UV like before? And we didn't know. Now we know. Okay. And again, why do we care? Who knows what this is? Mahi, dolphin fish. You like fish tacos. Mahi are an incredible species of fish in many ways. They're fast, they're voracious predators, they live near the surface. They're awesome fishery food. They grow really, really fast, so they're healthy for you. They don't accumulate pollutants, but they also have an interesting life history. So here's a cartoon of the slick. All of the small volatiles go away, and the heavier PAHs that can cause phototoxicity stick around. Mahi show up, and when they want to spawn, they spawn near the surface, and their eggs are spawned. This is a video of mahi eggs. Note how little pigment there is. Mahi eggs are buoyant, and they spend the first 4 days of their lives within the top 3 to 5 meters of the water. So they float up. After they hatch, they go down. They're fairly tolerant of just UV, but what we've found is that their eggs and the hatchlings are extremely sensitive to this PAH phototoxicity. So even out here where the whole water column is affected, it's one thing. You get anywhere else, it doesn't matter how deep the UV goes. Mahi are going to be affected if their eggs are spawning. And so the white bars are the impact at 10% UV. So at the bottom of wherever we've been, you get down here, and within the water solubility of the chemicals, you kill 50% of the eggs. At full sunlight, we get about here, and it's 10 times less. These are very low numbers, okay? So mahi are sensitive. So significant numbers of mahi will be impacted if there's an oil spill during the spawn.
But we can still eat it when there's not an oil spill.
Oh, yeah. Yeah, absolutely. Eat all the mahi you want. They're great fish. We can talk about my soapbox about what fish to eat later. Okay. So that's the potential for phototoxicity. But now I want to ask you a question. So part 4, after the slick is gone, reprise. Here's the question. What's the biggest casualty of an oil spill?
Economics.
Economics? the environment. Come on. Birds. Fish.
Stock values.
Stock values. Yeah, economics. Mental health. This is something that before the Exxon Valdez oil spill, we really didn't appreciate. And then we appreciated it, but we didn't really appreciate it until after the Deepwater Horizon. So only a few thousand people were affected by the Exxon Valdez. Millions of people were affected by the Deepwater Horizon. And since those two oil spills, hundreds, if not close to 1,000 peer-reviewed published papers have been published on the long-lasting negative mental health consequences of a trauma like a major oil spill. And so this is a word cloud from the titles of 300 papers that shows, just give you an idea of some of the words in the titles. But the real thing is that all of these papers show that for years after an oil spill, there's double-digit percentage increases in rates of depression, post-traumatic stress syndrome, domestic abuse and arrests, I don't have it on here, divorces, high-risk alcohol behavior, and increases in alcoholism, and suicide. So commercial fishing captains have the highest rate of suicide after a major oil spill than any other group. Correct, yes. Yes, so these are the coastal residents, the people that are involved in the fisheries, the coastal residents, and the people involved in the oil spill cleanup. So in the Deepwater Horizon, the fisheries was closed for 2 years. You've owned your shrimp trawler who was owned by your father, who was owned by your grandfather, who was owned by your great-grandfather, and you went out of business. That's got an impact, and it lasts a long time. So ecosystems recover from oil spills in 10 to 20 years, a decade or two. Mental health consequences last for generations. I've been to Cordova. I've talked to people that were in Alaska. I've talked to people there. They will never get over the Exxon Valdez spill, and they passed it on to generation after generation. It will last for lifetimes, the impact of that oil spill. So let's not just do doom and gloom. So summary, how am I doing on time? We're good? Oil is a highly complex material. It's got beneficial uses. We couldn't live without it, but it's got detrimental impacts. Unknown. We know there'll be another big spill. We just don't know when or where. Tens of millions of gallons of oil are transported up current of Ceiba in close proximity to us and the bank every day. There's more to oil spills than just the slick, so hopefully you've learned a little bit. And ecosystems recover from oil spills in a decade or two. Mental health impacts last for generations. So what can you do? First, advocate for industry best practices for oil transportation and distribution. The best remedy is to prevent the oil spill from ever happening here. Because once it happens, you can't get it back. You can't just go out and get the oil. Especially here with the waves. Booms are great. They help contain oil, but it has to be calm seas. Once you get above a foot or two of wave action, the booms are above the waves and the oil goes out. And there's big waves here.
What do they do with it? It's been in the water.
They pump it into
and they have to.
They pump it into dumpsters and they haul it inland, and then they either use it, sell it, or they burn it. If they can't siphon it, they corral it like I showed you in the BP spill, and they burn it. And if they can't do that, they put dispersants on it and they sink it.
Yeah, but once they pull it up from the siphons and stuff, is it contaminated? Can they actually use it?
No, you can use it. You can use it as tar and asphalt and that kind of stuff. Yep. Promote the collection like this trip here. So like I said, I'm at work. Promote the collection of baseline ecosystem data to facilitate management decisions and priorities. This is a highly sensitive ecosystem. This should be a high priority for the local and regional governments. And finally, prepare. Prepare for the chance that the next big spill happens here. Mitigation and remediation strategies. What do we do? Protection and management of sensitive areas. The Ceiba Bank's critical for this area, and Ceiba Island is critical for the economy of the area. And then finally, and unexpectedly, make sure that you have in place the infrastructure for long-term support for human health and well-being. That's a critical feature. That is, to me, maybe the most important feature that I want to get across for you all. So that's my talk. I lost track of time. I don't know how long we went. About an hour? Okay. So what I want to do now is thank you. We're going to switch the slides over back to the survey. And now what I want you to do is either pass the sheet around or get back onto the site. And now tell me what 3 words you think of when you think of oil spill. Okay? So Tiffany will switch it over, and I'll take questions, and we can talk. Go get yourself a beer, and I'll be here for as long as you want. We can chat and discuss.
Back here.
Andrew, yes.
All right, so mine might be a little long. So the statistics I've learned about oil and hydrocarbons in the ocean is, this comes from Project Aware, Patty's nonprofit that helps environmental cause, is that 14% of hydrocarbons in the ocean come from marine disasters, spills like Exxon Valdez, etc. Approximately 40% come from transportation like car, automobiles, and rainwater runoff. And then there's still a huge percentage of hydrocarbons that are put out in the ocean through natural seepage. Could you comment on natural seepage? What's happened historically throughout all of time with oil emitting up from seafloor seepage, and maybe its effect on how the globe actually processes it?
Right.
If you can comment.
Great, thank you. Yeah. Happy to try. And again, I'm not an expert in this topic, but I'll give you what I know. It's my opinion. So there's a lot of oil released in natural seeps. I'll take the natural seeps first. There's a lot of oil released around the world through natural seeps and underwater. But it happens in relatively gradual ways compared to a tanker accident, which releases millions of gallons of oil at a time. So there's a big difference there. A seep is a seep. And there can be significant amounts of oil released from a seep, but it's relatively contained in a decently sized geographic region, and it's been happening for thousands or hundreds of thousands of years. So the organisms that live in that region are naturally adapted to that oil in that area. And that's where I was talking about at the beginning, where the microbes have adapted. They use the oil as food. Okay? They eat the oil. They use it for their metabolism. They metabolize it, they use it, and they degrade it naturally. So again, in areas where there's a lot of oil, so even up in Prince William Sound, there's oil seeps, and there's naturally adapted bacteria that can eat the oil. The areas that they left go, they cleaned up what they could and left go, those areas, the microbes degraded the oil over a period of 5 to 10 years. The areas that they steam cleaned are still sterile, and the oil that was left behind is still there. So it's critically important that those natural seeps happen. Other sources, so combustion and runoff, those are important sources as well. It's not just oil spills. When I worked in Lake Tahoe, we weren't concerned about oil spills. We were concerned about engine exhaust from jet skis and outboard engines. And the exhaust, the combustion products, many of them are just as or more phototoxic as the things that we see in oil. And most of my career has been studying the combustion products of oil, not the native compounds in oil. So that's another major situation. But again, unless there's concentrated boating traffic or shipping traffic, those things out here are fairly dilute. When you get into a marina and there's ship traffic or boat traffic coming in and out, it can be a really important phenomenon. But in general, you get out, so when we start the ship in the harbor, there's diesel fumes, and that, when we get out into open water, you've got trillions of gallons of water, and it's diluted almost infinitely. So there's a difference. But let me finish for the major thing, the major difference about those kinds of shipping accidents is that millions of gallons are released all at once in a concentrated area.
If I can get a quick follow-up. So the real fear is the concentration and the immediate impact versus, let's say, the fear of global warming, which could historically alter the planet. Would oil spills historically alter the planet versus naturally absorb over 10 to 20 years? Should this be something that in a culture of fear, you know, and some with environmentalism right now in our day to day, is that something, you know, historically or after 10 to 20 years you say, oh, this area rebounds and rest assured it'll come back?
Yeah. So most environments will come back, and it takes 10 to 20 years on average. And so it's a disaster when it happens. There's major impacts. It can completely change an ecosystem. So for example, in Prince William Sound, one of the things that was totally unexpected that happened after the oil spill was, since the oil is used as food by a lot of organisms, there was actually enhanced production. So algal growth and plankton growth went up for like 5 years after the oil spill. And the herring fishery was closed from 1989 to 1992. Well, the herring fishery is really managed tightly, and the take of the herring kept the population suppressed. So two things happened. Oil fertilized the water, so the plankton increased. The pressure from fishing was released. There was more food, and the herring population skyrocketed, just went way up. And western Prince William Sound and eastern Prince William Sound used to have two separate fisheries populations. But the number of fish went up so high in that 4-year period, that 5-year period, that they actually mixed in between. And eastern Prince William Sound had a disease that western Prince William Sound didn't have, and the eastern Prince William Sound population of herring were adapted to that disease, but the western Prince William Sound weren't. Once they mingled, it was like the Europeans coming here and sharing syphilis to the natives. So the western Prince William Sound fish crashed. The herring fishery crashed. But then when the food went away after the oil got degraded, there wasn't enough food for that population, and the eastern Prince William Sound herring population also crashed. And there hasn't been a viable commercial herring fishery there since 1992. So that's an unknown thing that happened. So there can be long-term, almost permanent impacts due to a single event, but it's these weird kind of indirect effects things. So thank you for that question. Yes.
So I was an English major, and it was a long time ago. But one of the few science books that I've remembered reading, and I've thought about it 8 times during your presentation, is E.O. Wilson's *The Diversity of Life* from back in the early '90s, maybe.
Yep.
So I guess I'm thinking of 2 or 3 things that the thesis of that book, I think, was essentially that biodiversity was what mattered the most, because whatever the disaster, the sheer vastness of the numbers of different species that could come in and make a stage of recovery, was the true resiliency of nature and the earth. What you just described is a situation where there was diversity, and yet both parts of it were annihilated after a disaster. and I'm wondering, we're hearing a lot about more extinct species and less robust species populations. Are we perhaps at a point now where, or are we approaching a point where the kind of recovery that we saw after Exxon Valdez, after Horizon, might not be possible any longer because we don't have the diversity?
That's a great thought and a great comment and a great question. So the answer is yes. Yeah, so the question was, E.O. Wilson is a famous ecologist and diversity person, and his premise and others, my favorite is Stephen Jay Gould. I haven't read as much of E.O. Wilson, but the idea is that the diversity of life provides resilience to environmental impacts, either long-term or short-term. And the more diverse an ecosystem is, the more resistant and resilient it is to impacts to the environment. And the question is, since we've reduced diversity, could that have an even bigger impact if there's a disaster? And the answer is absolutely yes. So we are experiencing in our lifetimes, the largest and most rapid mass extinction event in geological history, driven by human impacts. And it goes from everywhere from farming. 200 years ago, we depended on maybe 30 to 50 different kinds of plant species and 5 or 6 different kinds of protein. Now we have 3 kinds of protein and 5 plants, and we grow them in monocultures. And if there's a disaster, the diversity is not there to recover. So if we lost all our soybeans and all our corn, we would be in serious trouble, right? And if we lost all of our pork and our beef and our chickens, we would be in serious trouble. There's no diversity there, okay? The same thing is with fish. Fish are under serious declines around the world. And the diversity of fish is decreasing, and the resilience and resistance of those ecosystems is decreasing as all of these other things happen. So when you have a major disaster, then there could be a complete extinction of everything there with little recovery. The only thing we're pretty sure that'll survive the Holocaust is bacteria and cockroaches. Because they've got genetic diversity. So there's species diversity and there's genetic diversity. Within a species, if there's a lot of genetic diversity, they're pretty resilient to different things. What's that?
Oh, if we still have bacteria, eventually something new will evolve.
Something, yeah, but it'll be 3 billion years again.
You know.
Yes.
You mentioned about the dispersants. Sorry, I can't say that word.
Dispersants.
Thank you. That they put during our oil spill. So what happens to it? Is it like sink to the bottom, and then what happens?
So have you ever had like greasy, oily dishes and you put your dish detergent on it, and it goes from a glob and it goes like this? It helps solubilize the oil so that you can get the oil off of your dishes. Same thing happens in the ocean. It helps it turn water soluble, and then it can distribute through the water column, and it basically sinks the slick and dissolves it into water. Does that answer your question? Okay. Yeah. It basically makes the oil more soluble.
But it's toxic to the...
The soap itself, the dispersant, is pretty toxic, yes. But it's like this lesser, which evil do you want? Do you want the slick, or do you want a short-term toxicity to get rid of the slick?
So it lasts short term?
Relative, yeah, the exposure, the dispersants are pretty short-term.
They disappear? Like what happens to them?
They dissolve in the water, and they disperse, and they're also eaten by bacteria. Oh, we got questions online?
Yeah.
Awesome!
Some questions from Facebook.
Hi out there!
Yep. So we got 2 questions from Facebook. The first one is from Bill Oris. So his question is, clearly tanker traffic presents significant possibilities for spillage. Is there any concern coming from large passenger ships?
Yes, there's concerns about large. Thanks, Bill. I've got 5 brothers. We might get 5 questions. Passenger traffic can also cause issues. The question was, we talked about oil transportation. Sorry, I need to repeat this on the speaker. The question was, we've talked about shipping and oil transportation, but what about like large cruise ships? So large cruise ships can also have impacts. They may be smaller than an oil tanker that holds 20 million gallons, but they have lots of oil in their oil tanks to drive the boat. Lots of oil. So if they run aground or there's an accident or they break apart in a storm, cargo ships and passenger ships have significant amounts of oil in them. And if that's released in an accident, then you have a minor oil spill, but depending on where it happens, it can have significant effects. They also burn tremendous amounts of oil, and those combustion products can get into the environment and also have some impact. So they have relatively minor impacts, but they can have significant impacts depending on the ecosystem.
Okay. Next question, if you could please read it.
Oh, there we go. So this is from Chizzy Sab, and I promise I don't know you. Is it true that the main purpose of the oil plant on Statia is to transfer the oil into double-hulled tankers because single-hulled tankers are not allowed in U.S. waters? I can't answer that question factually. Only from what I've heard is that Statia will take single-hulled tankers and transfer the oil into their tanks, and they will transfer it back to double-hulled tankers to go other places. So that's the best I can do with my expertise.
And I did find one more.
Okay. From Aaron. What is the average amount of oil a ship carries per load? So the average that comes in and out of here from Statia, at least within the last month, was about 13.5 million gallons of oil. Okay, so that was the average size per day, and so there's up to 3 ships per day, so in that range. Okay. One smaller question.
It's about the mahi.
The mahi. When is their spawning season? Every day. No, it's not every day. So when do mahi spawn? Springtime. That's my opinion. I'm going to guess. I'm got to confess, I'm not a fisheries biologist. I am a toxicologist. But I think they spawn in the spring. But I know that at the University of Miami, not Miami University, but the University of Miami that did a lot of the mahi work, they're spawning mahi in their artificial tanks almost all year round. Okay.
You said the spills happen about every 20 years?
On average, we've had a major spill every 20 years, yeah.
The last one was 2009?
2010.
We've got another 10 years.
Yeah, Andrew.
Yeah, so you talked about after the spill quite a bit, and you see the images of the guy with the diaper on the beach and things like that. Is it, in your opinion, laughable with cleanup efforts after the initial spill, or let nature take its course and just eventually cleanse? How effective is our protocols now after a spill to effectively clean up the disaster? Or is it for media pictures and, oh, we're cleaning up the diaper? Meanwhile, there's, how effective is that immediate response?
Right.
Is it
so that's a great question, and the answer is it's mixed. Okay, so the question again is, are the measures that are taken immediately after the spill, are they really effective and necessary, or are they more for the visibility so that it looks like we're trying to clean it up, or should we just let it go? And the answer is mixed. So we try to collect, and there was a lot of oil recovered from the Gulf oil spill, a lot of oil. So like large barges of oil were recovered.
Do you have a percentage possibly?
I do not. I don't. It's small, okay? Single-digit percentages is my opinion. But I don't know. I know it's a small amount. But every gallon of oil that you can get out of the water is a gallon the ecosystem doesn't have to deal with. So it's critical to try and get as much as you can out. To the extent that it's a visibility thing, how many people were alive in 1989? Some. Do you remember the CEO of Exxon, what he said? As close to a quote as I can get is, "We will get every drop of oil out of Prince William Sound." That was for visibility. That's why guys were on the beach with diapers. They could have left most of what was beached there and it would have been gone in 10 years, but that was the visibility part. So it's a bit of both. The steam cleaning part was an idea that somebody had to try and get as much oil off the beaches as possible because the CEO of Exxon said we were going to get every drop of oil off the beaches. It really wasn't necessary, per se. It had its impact. They could have wiped up as much as they could and let the bacteria do the rest of the job. But the steam cleaning ended up sterilizing the beaches and caused longer-term damage than the oil did. So there's a mix. It was a media circus. I've heard stories about the Exxon Valdez, not so much about the Gulf oil spill, because we did it better this time. But there was a media circus. So there was hundreds of people behind that guy mopping up the oil, taking pictures and doing video because it was on the news. I knew somebody, and I'm going to use profanity here. I knew somebody who was on one of the cleanup crews for the Exxon Valdez, and after 2 weeks, he quit. And his resignation letter was, "Dear boss, I quit. You're doing more damage by having thousands of people pissing and shitting in the woods than leaving the oil doing what it did." Yes, sir.
Has there been any success with reintroducing the bacteria to the areas that were sterilized?
Yeah, so one of the experiments that was done in one of the non-sterilized areas and then in one of the sterile, they actually added nutrients and inoculated bacteria to those systems, and they accelerated the cleanup. So this bioremediation is something that was pretty effective.
So
Tim.
these biologics that eat the oil, doesn't that just run down the chain and the toxic effects still cause damage down the line?
Okay, so the question is, do the microbes just move the toxicity down the chain? No, they're using that as food. So they're taking those hydrocarbons, they're splitting the carbon and hydrogen, the carbons apart from each other, and the energy in those carbon-to-carbon bonds is used for their metabolism. So they're just like when we eat food and we metabolize with CO2 and the other waste products that we have in our urine and feces. That's what they're doing. They're breaking it down into carbon dioxide and water. So they're detoxifying it.
Can they be controlled?
Can they what?
Can they be controlled?
Yeah, and that was one of the questions about bioremediation. You can go collect bacteria that are adapted to use the oil as food, and then you can put them into an area that has oil to help it degrade. But you don't want to take bacteria from the Gulf of Mexico and bring them here to Ceiba. So you would want to culture the bacteria here in Ceiba that are pre-adapted to the oil and then put them out.
As in, can you already start doing that for just in case something bad happens here, or is that too?
I suppose you could, but it's pretty far out there. But this is what I'm talking about, the baseline information, is that we have techniques now for the genetics to analyze microbes in a way, rapidly, in a way that we've never had before, just in the last few years. And if you could get funding to go out and find those species of bacteria now, that if we had the funding to do it, you could identify which species are present, and then you could culture them very quickly if there was an accident. Shall we do that?
No. I have no clue what the station, who the owner is of all the
Okay.
oil
Yeah, it's turned around. Yeah, so someone was asked, should the oil terminal be responsible? And I can't answer that question. That's a question for the regulators and the managers and the people of the Dutch Caribbean. Right? I'm an outside expert. I can talk about my thing. I'm not here to talk about policy necessarily, but hopefully what I've done is given you the interest and the impetus to be the advocates for the right decisions to be made. So I'm being told that we're wrapping up. I'm pleased to be here. I thank you for your time and attention. I'm around for as long as you want me to be to talk offline. And thank you and appreciate it, and we'll hopefully be back.
One last thing, guys. Hang out 1 minute. Real quick. Thanks again, Jim, for that very eye-opening, mind-blowing, interactive presentation. Another round of applause real quick. Thank you. We have some upcoming events for you guys for See and Learn. On Wednesday, we have another presentation by our Galaxy expert, Sydney Lower, at Scouts Place. Then on Friday at Hideaway is Dahlia Hassel, and she will be presenting on coral nurseries. Then on Saturday, we have double field projects. You can go on a shark dive with Chelsea Black, who's our shark expert, and also a stargazing tour with our Galaxy expert, Sydney Lower. On Saturday at 9:30 p.m., meet at the See and Learn tent. Finally, we'd like to thank all of you for coming. Enjoy, stay for dinner. Thank you, Lollipops, for hosting. Thank you, Facebook. Yes, thank you, everyone, for your wonderful questions. And we'd like to thank all of our sponsors, particularly Carib Trans. And everyone have a good night. Stick around, ask Jim questions. Good night. Thanks, guys.
Miami is known as an international community and the hub of trade and logistics for the Caribbean and Americas. A leader in the freight logistics industry, Carib Trans has served the Caribbean region for more than 30 years, with a footprint that has grown from one island to now serving the majority, as well as Central and South America. Carib Trans is an NVOCC, a non-vessel operating common carrier, meaning it has the same responsibilities as a shipper without owning the vessels or planes. Its primary customers, individuals who ship clothing, electronics and other personal items, and occasionally cars.
Most of the stuff that they're sending is because they don't get it there. So for us to provide it on two services, air and ocean, we can give it a choice of how fast you want it. So if you want it really fast, we're going to send it by air, you're going to have it next day, sometimes even the same day.
That on-time service has been the key to Carib Trans' success, whether shipping by air or by sea. The company moves about 5,000 TEUs of freight each year, more than any NVOCC in the region. And since it joined the Saltchuk family of transportation companies a couple of years ago, Carib Trans can offer customers even more shipping options.
Other NVOCCs, they depend on other shipping lines that are not part of their family. So they need to rely on whether they're going to sell or not, whether they are late or not. It doesn't happen to us because it's part of our family of companies. We control the service that we give.
Sí, buenos días, por favor, con Diana.
Quality service is what keeps customers coming back. Customers are treated like family, and when they leave to research competitors, it doesn't usually last long.
They have left and they have come back because they've said that, nobody does it better than Carib Trans. So because of that relationship.
That exceptional service includes consolidation. Customers can have freight sent here and stored for free for up to a month, then consolidated and shipped on to the islands and Americas, a perk for the region's growing small business market. Puerto Rico is an expanding market for Carib Trans, about the size of Connecticut and rich in history and culture. Puerto Rico is home to many pharmaceutical manufacturers, as well as a thriving tourism industry for which Carib Trans moves raw materials and supplies. But serving small businesses is still the company's bread and butter here in San Juan. Businesses like Caldera Café, a local coffee company. Owner Alfredo Rodriguez started growing coffee beans at his mountain farm about 20 years ago. He recently ordered a variety of new equipment for his farm and shop. He uses CaribTrans because it consolidates shipments, which cuts down on the number of times he has to pay the Puerto Rico import tax.
Not many companies want to do that. They want only big cargos and maybe half container or full containers, but they don't want to consolidate because it's more difficult.
Turning challenges into opportunities is what CaribTrans does. That includes helping to grow small businesses like Caldera Café by taking the hassle out of shipping.
We can be a gateway to expand their business in the Caribbean and back to the U.S. And wherever they can sell their products, we are also going to be a partner for them.
That customer dedication has made CaribTrans what it is today. Now, as part of a larger family with more transportation resources, CaribTrans hopes to grow beyond its current market, offering services to additional Latin American ports and eventually Europe and Asia. But even when it becomes a global logistics company, CaribTrans wants to stay true to its roots, always providing personalized, reliable customer service and a commitment to the communities it serves.